Now I will read questions from the question box and ask one of our presenters to answer them. With the CIR process, is segregation typically an issue?
It's a very fair question, and I've seen that segregation can be an issue. Generally, it has a lot to do with the instances I've seen. It might be resolved with some of the configuration on the paver screed, for example. A lot of times we see segregation out at the edges or even in the middle where, we have to change the way the material's flowing under the screed. I've also seen segregation issues where we have excessive buildup in the wings of the hopper and it's not managed properly. More often than not with the multi-unit trains, I don't see it as much with the cutting process because of the extra screening deck that can help make the sizing more uniform. So a lot of it could be the part of the roadway, but there's a component where I think the contractor and the paver could probably do a little bit more to help with that. Don, I know you might be able to add to that.
Yeah, I think you covered it. CIR typically is a little larger aggregate. We're crushing over 1.5 inches or an inch screen. And then it's just a matter of best paving practices. As Jason said, you can minimize it by folding up your paver hoppers. If you lay it on the ground and then letting the windrow elevator mix it again, but it's just typical larger rock on rolling to the sides, and it takes good paving practices to get rid of it. Typically, if you do, then you don't have an issue with segregation.
And the next question is, how well does HIR and CIR work with chip sealed roadways? Does the chip seal have to be removed first?
That's another good question. We see that a lot. From the perspective of heater repaving guys, we've seen it done both ways. I think personally, it's a good product to recycle and incorporate into the process. It's heavy with binder. You've got some aggregate in there that you can reuse. And if it's an old, worn out chip seal, as typically we see on some of our urban highways that we're recycling, it does just fine. You can get in some problems if you've got 2 or 3 vintages of chip seals on top of the roadway you're trying to recycle. So we have milled that off before starting the recycling process, but if it's manageable and not a super thick chip seal or chip seals that are on top, those can be recycled in the hot in place process just fine.
For the CIR process, I would say a lot of the rural projects we get the opportunity to be involved with, oftentimes there's chip seal. I mean, it's almost common. When there's an excessive amount or just consecutive chip seals, that's where kind of the material scoping and the mix design process might help better understand if some of the other additives are needed, particularly corrective aggregate and or some other type of additive like a cement to help maybe neutralize, some of the excessive asphalt in there. I haven't seen a project where you need to mill off the chip seal to do a successful CIR to date.
I'm going to just add one is if it's an emulsion chip seal, typically it's not a problem. We have had some issues with an asphalt rubber chip seal that had a little issue of gumming on it. A couple projects we just recycled through it. A couple projects though, we actually found the gumming was so much we removed the chip seal, but that was only when it was an asphalt rubber. If it's an emulsion chip seal, we don't worry about it in CIR.
Next question is, what does corrective aggregates do?
A lot of times what corrective aggregates can do, you can bring in some extra material, some maybe more angular, some more stronger material to kind of act as more of a load-bearing portion of your CIR mixture. Can correct gradation a little bit if you have a gap gradation. For example, if you have an open graded cold mix and then layers of chip seal, you might add something a little more dense graded in there to help lock up the uniformity of that mix, because now it's going to be a dense graded structural bearing layer. It also is used when you need to add material volume. So for example, if you're widening or you need a thicker layer, that corrective aggregate, it can help give you more material volume for extra thickness or width of structure.
You may have cut out on this.
I'll throw something in too. It's adding headstone, especially in CIR, is not that common.
I think it's pretty commonly used in heater remixing process, and again, that's to either take up volume or improve stability of the mixture recycled layer that you're putting down.
Yeah, I'll agree with Steve. It's rarely used in CIR.
The next question is, would CIR or HIR be a solution for residential streets where mainline runs would only be 500 to 1,000 feet in length?
I'll jump in. Used very commonly in urban sections. As an example, Cutler Repaving does a bunch of work for the city of Denver, and it's block after block after block. It gets a little tight with just the sheer length of the paving train, but it's commonly used in urban sections.
Next question. Can you do CIR on previously recycled material?
Yes.
Next question.
Yeah, I think you can.
Sorry.
I haven't seen it yet. We've done a partial CIR that was formerly a bituminous FDR. So again, just with the scoping and the mix design and understanding what components you're putting together, I think it's definitely doable.
Yeah, I was going to say many years ago, we CIR'd a couple of roads in Kansas that had been CIR'd before. Now they had an 1.5 inch new asphalt overlay on top of them, but yes, they've been a couple of them. I'm aware of a few that have been done twice.
Nevada has done it, several of them too.
Next question is, can chip seals be incorporated into a CIR?
Yes, we
Okay.
can, and we've talked about that.
Yes.
Next question. For CIR, what is the target density and air voids? Is there a problem with rutting with normal legal loads if only a chip seal is put down on top of it?
So the first part, the density requirement is generally, the target density in the field is generally determined off of a growth curve. And then we are targeting a high percentage of that growth curve to ensure that we're getting density throughout the project, or at least that's how we do it on a lot of projects here in the Midwest. Typically, we don't specify or design to an air void content. And part of that is you can't really predict the crushing and the shaping, up front to say this is, where it's going to be. I missed the second part of the question. If you could repeat that.
Is there a problem with rutting with normal legal loads if only a double chip seal is put down on top of it?
I think a lot of that is dependent upon the total structure. So considering that there is a very strong, adequate base subgrade below the CIR, if there's a significant amount of legal loads on top of it, I'd be a little more concerned on the repetition. But some of the rural highways that we've seen here in the Midwest with double chip seal, they're getting probably heavier than legal in some situations farm traffic, and there typically isn't a rutting situation that we see.
Next question. What is the structural coefficient difference between HMA and CIR?
I'll answer that one. It's about 80%. ERA typically recommends you use somewhere on the range of 0.36 for a structural layer coefficient, and 0.44 is what's typically used for asphalt. There's some research out there that indicates that may be conservative, but it does seem to work quite well.
Next question. How long does it take before you can allow static loads on CIR?
That's a really hard question to answer because there's a lot of the environmental effects that go into that. So, Don, have you got a suggestion on that one? I don't know how to best answer that.
Well, it depends on what you're using. If you're using a foam, you're looking at probably, depending on the product, the wrap, the material, that type of thing, a couple of weeks. And then an emulsion, though, you got to wait until it fully cures and set. But the answer is, what static load? I mean, we park vehicles on it all the time. Forklift loads, outriggers, those type of things. It's going to be dependent, but you're essentially, until it hardens up, and that could be just a few days to a couple of months, depending on the weight of the load, the pounds per square inch, that type of thing. It is a challenging question, to say the least.
Yeah, that's a real hard one to answer without some details around it.
Next question might be easier. What determines if asphalt or emulsions are to be used? I have an open question.
I guess I'll make a stab at that one. A
Go
lot
for
of
it.
it has to do with just the experience of the contractor and what they prefer. And then the other one is availability of materials. There really doesn't seem to be very much good evidence that there's a difference in performance. There are differences in the way they behave. Emulsion is a coating technology. Foam is a binding technology. You do have to deal or work with it's not something can't be overcome. It's not a huge issue, but you are working with 325 plus degree asphalt if you're using foamed asphalt. Whereas, so you're making connections and stuff that you've got to be very careful with. It tends to just be either agency or contractor preference. You other guys can chime in if you want to.
Yeah,
Yes,
next
the availability component
Oh, sorry.
is the biggest part of the availability component is a big part, especially when you have to haul the hot AC long distances to maintain that temperature. It's hard for some of the terminals to hit that temperature in the haul time. Completely agree with that.
Yeah, very good point.
Okay, the next question is, can you use a slurry or microsurface as a working course over CIR or CCPR?
I've seen those used in conjunction with a chip seal in a cape fashion. I'm trying to think if I've seen just a single slurry or a micro on top without that chip first applied. Don, how's your experience been on that? Have you guys been putting micro straight on CIR?
Yeah, well, you know what? On all of it, it depends on the design. What is the material that's going to be underneath supporting? What is the material that you're recycling? How's it going to behave? You've calculated the mix design. And then it's traffic loading. So we've done it on low volume, really low volume areas where we've just cold in place recycled or closed central plant. Put chip seals typically if it's in a low volume highway. But on some parking lots, we've done it where we just put a microsurfacing on top of it, and it's held up well. It all depends on design. All these questions are all about design. What's the supporting material underneath? What's the material recycling? Check it in the mix design, how the wrap is going to behave, and then what's your traffic?
Next question is, what kind of plant do you need for CCPR?
Well, I've seen the guys that have the multi-unit trains will a lot of times just park that processing unit and run it through there. If not, you just need a pug mill mixer. It needs Don, or you might be able to go with what's actually required for the metering and all of that.
Steve, you said it well. It's typically just a dual shaft pug mill mixer is what you want. The drum plants don't do as well. They don't coat as well, especially when you're using emulsion. A pug mill mixer, and then something to size your aggregates. Whether you're going to do a scalping hopper and use millings directly and just pull off your oversize, or a crusher beforehand. And recycle trains, they have those all built together. Multi-unit trains have them all together that you can put them in, or you can do them separately, crush and screen the material, and then feed it and put it through a pug mill. We do use, I think almost everybody uses a mass flow meter to control the asphalt emulsion on it, and then a meter for your moisture and your additives, whether you're adding cement or lime, any other additives.
Yeah, if you are using a foamed AC stabilizing system, you need a pug mill with the capability to do the foaming within it as well. That'd be kind of not conventional pug mill when you need to do the foaming.
The next question is a little open. So it is, any comments on why in-place recycling versus 100% wrap, and why in-place is better?
I'm assuming you're talking the difference between in-place recycling and like a cold central plant mix, and why one is better than the other one. The in-place recycling will be considerably more sustainable because you're not hauling or trucking materials. But the performance, the mixes are almost identical. The performance should be the same as long as they're properly designed.
Next question. Quick lime versus hydrated lime in CIR, what is recommended?
Both of them are ultimately going to be a hydrated lime, but we recommend quick lime that you batch and then you put it in because you can pump it into the water. The reason for is you can use less. It gives you a little heat of hydration, and it's cheaper than trucking all the already hydrated lime. So we recommend quick lime that you essentially batch and hydrate on site and then put into the equipment.
Yeah, there's been some research studies. You slake the quicklime on site, it'll perform better. It has a finer particle size than the hydrated lime. Works a little better. Has a little heat with it too, which helps.
Next question. How does the open texture nature of CIR surface affect long-term performance?
Well, you want to be sure it's
You know
covered.
what?
Yeah, but go ahead, Jason.
Yeah, I was going to say, we say that it's a higher void content, but this stuff doesn't have an excessive void structure that looks something like an open graded friction course or like a permeable pavement. The way I like to describe it is we just have probably more smaller voids in there. So the reality is it's not, a severely open graded looking type material. But I agree with, what Steve was saying is, because we do have that higher void content, it's important that we get a proper seal on it just for, keeping the elements and helping with the durability.
The next question is there's a few different parts. The first part is, can we get some quick discussion about longitudinal joint construction during CIR? And do typical HMA best practices apply for CIR as well? Is brooming and broadcasting that joint a bad idea?
There's a lot of parts there. Could you read the first part again, please?
They're asking about longitudinal joint construction during CIR. Is there anything special that has to be done?
I think in general, best practices, still apply, especially with the CIR. And, it's important to remember, depending on when you're doing your turn or your flip and you're coming back, and working that joint, that material still might have a little bit of opportunity to gain density in it. So I think your best practices are very similar. Now, there are some nuances with the material, like, we're not turning the temperature on at the screed, and trying to understand, I said, fluff of material. So when you're doing CIR, let's say on a 2-lane road, and you go down, you need to do the contractor needs to be conscious of the head of material in that joint, because when he comes back and matches it, there's a little bit of fluff with the CIR. So I know that's one area that experienced contractor can really make or break performance and constructability. Don, I don't know if you got anything to add to that from the contractor's perspective.
Oh, yeah, so we're talking about longitudinal joints and cold in place recycling. Am I clear on that?
Yeah, the question was, can we get some quick discussions about longitudinal joint construction during CIR?
Most of the time in your longitudinal joint, you're going to cut into the existing, you do a path, you do a path, so you're cutting an existing road, and you're going to have just kind of on, let's say on one side, you're going to have a little bit of a slobber over, and as Jason says, good practices, pinching the roller back and on. But the other is you really don't have the issue that you have a hot mix, because you're not placing a joint and then coming back and reheating it. You're actually cutting in a few inches to do it. So when you're doing it, you're actually cutting in any material that's on the edge and then compacting against it. So just good roller patterns on it, but you actually have less issue on CIR joints, because you're cutting in and destroying any slop over from the first joint. Jason, am I answering that question correctly, do you think?
Yeah, I think we're saying a lot of the same thing there, Don.
Okay, good.
And I think it's a little different if we're talking about cold central plant, because that material might move a little bit different unconfined than hot mixed would. Would you agree with that, Don?
Unfortunately,
yeah, absolutely. A little bit better practices when you're doing cold central plant recycling. Cold in place recycling, you're going to cut off that slough.
Unfortunately, we've reached the end of our session limit. It is now a little bit past 1:45. We do have more questions that we unfortunately won't be able to get to. Once again, I'd like to thank all of our presenters. At this point, this concludes session number 6. Thank you for attending. It is greatly appreciated.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.